Hello? Hello? Just, oh, well, perfect. Hi. Good afternoon or good morning. Good noon. Okay. Hi, welcome to my talk. I hope you had a nice party yesterday night. I had a nice party, but didn't drink that much because, yeah, the talk going on. Hi. So, that's my rambling about security issues. I'm a bit sorry that's going to be a rather depressing talk, but yeah, you decided to come, so tough luck. Hi, so I'm a long-time Python core developer and security guy from the Python community. I live in Hamburg, been using Linux for a long time. And also, as you might guess from the slides, I'm employed by Red Hat, doing also security thingy stuff, so working on identity management, so certs, Kerberos, LDAP, other fun stuff, yeah. So, what's my talk going to be about? This is going to be a mostly in-breath talk. So I'm not going to go into that many security issues in specific, rather expose you to as many security issues as I know of, just to give you a broad idea what could go wrong, what you may take into account when you develop software. But first of all, why should we actually care about security? So security is actually rather hard and expensive, but on the other hand, I consider myself like a proud craftsman. So I like my job as a software engineer. I think as an engineer we should be responsible for what we are doing and not slack, especially when it comes to security. On the other hand, if you're doing business, then although it's expensive to hire security engineers, it's also critical for your business. To give you some examples, you may know Yahoo. They lost like 1 billion accounts a while ago. Actually, 3 billion accounts a while ago. And that was rather expensive for them. So initially, there was a company who wanted to buy them, and they said, yeah, I want to have $1 billion discount for that. Eventually, they settled up like 350 million discount, give or take. So if you have 350 million bucks on your account too much, please talk to me afterwards. But it's not just about money, it's also about actually life and death. On some rather trivial cases, like if you had a pacemaker and if you have a bug in your pacemaker, and just to recall a pacemaker is a bit of a problem because you have to actually cut people open. That's painful, dangerous, expensive, and yeah. But even much more trivial cases like a dating site can be actually a life and death situation. So there used to be, or I think again, a site called SLA Medicine, rather ugly site about cheating on your husband or wife, and yeah, they had a data lake too, which some people, after they found out that they data was leaked, committed suicide. Or more troublesome, the site was also used by non-traditional male-female relationship just to find a partner. And you may know that there are some countries in the world where non-traditional male-female relationships are forbidden up to torture and death sentence. So if you care about the user, if you care about people, please care about security. So I hope that was a proper motivation to actually care. So who's not motivated to care about security by now? Please? No hands? Good. Job done. You, next up. So before we go deeper, let's start with the obvious way to define something, Google and us, Wikipedia. So information security is the practice of preventing unauthorized access, use, disclosure, disruption, modification, inspection, recording, or destruction of information. Yeah, that's a lot. Yeah, let's take that apart. So, information security. Prevention, yeah, obviously you want to prevent people from stealing your secret data, your diaries. You don't want your system read your diaries, yeah. Mitigation, another thing that didn't pop up in the last one, mitigation actually means that there will be something going wrong with your system eventually, but you don't want that small piece to affect the other pieces, so you want to add mitigations so any kind of security issue won't cause like a fatal breakdown. And I think I find important is auditing. When the S-word hits the fan, you want to know where it hit the fan and where an attacker maybe compromised your data. If it just happened to go into your outer networks and just got like your favorite YouTube collection, that's okay. You got your private key for your internal CA, you have a bigger problem if you roll all your CA, all your certs again. Recovery is also, especially if you talk about ransomware, make backups to recover your data. You don't want to spend like bitcoins to get back your data. So take recovery into account. And as a German, especially European in general, privacy is very concerning for us. We have a bit of history in Germany with like East Germany, West Germany. Yeah, we don't want any of the states to just spy on us. They turn out bad. But why is it actually so hard to just do stuff securely? Security is hard because we have very complex systems. So if you look at your mobile phone, what amount of code is running your phone, the amount of code is running in your car systems, even these days, just to start your engine, it's a highly complex system and there's nobody who understands the whole system. Also the way we design that, so we have like a weakest link issue. That even the smallest thing can go wrong, can just cause your whole building to collapse. I'll give you some more examples later. So especially like we build security like that, but actually it's burning too. So there are people who play also burning Jenga, just have a big pile of wood, they put it on fire and then play, and yeah. But I couldn't find a good picture of that, so. Security is actually not testable. So you can test for known security issues if you know where they are, but you can't test for unknown security issues. And even for known one, it's often very, very hard to test. Especially because our design, how we design software is, well, and there's way too many ways stuff can go wrong. And even if you know what could go wrong, if you analyze what's going on, hardware and software makes it really hard. But let's see, how do other people do that? So a very good example of good security is actually the airline industry. So last year, I think there was only a couple of deaths, were very small commercial planes. So any big commercial airlines, having more like 10 or 15 people on board, didn't have any casualties. That includes, if you can read that, a Airbus A330 losing its engine in the middle of the ocean. A big one, so the 2-floor plane with like a couple of hundred people on it, I don't know how many, 500 or so, they lost an engine and still, yeah, no casualties. While we at the computer industry, yeah. Yeah. The whole internet was down. And that was not the only case. We had like fun stuff with a webcam attacks where somebody just hijacked millions of webcams and flooded the internet. Well, the oil industry is actually good because they do rigorous testing on their machines. I can probably not see what's going on here. I'll show you that these are the tips of the wing, that the wing up test. That's a rather extreme but still mostly safe state for an airplane. And we don't have that in the industry because we actually have, to show you one of the crazy attack vectors, attacks like that, where we just take a microphone, listen to a computer, and find out your SA private key. Yeah, that's the Shamir, the S in the RSA feed does crazy stuff like that. Fun guy. And a whole level of things, like if you look at compilers can do funny optimizations if you know C code. So I'm trying to erase some memory here to remove my secret keys, which works if you don't optimize the code. So on left is unoptimized code, on the right, the compiler just decides, now you don't need that code because actually that code line, the red one, doesn't change the output of the function. So the compiler is allowed to remove that. But you need to know that. And especially CPUs are also fun. They're very complicated machine. These are all pictures from one of my first security talks about 5 years ago. I'm reusing the same picture, telling people CPUs are really dangerous. And back then, nobody believed me until the one. So CPUs are fun, and I don't understand how they work. Yeah. But even on the other side, if you have user-facing programs, these are two different strings, but they look totally alike. Now, so the fun stuff we work on browsers. You can have letters that look like other letters. Yeah. So, just a couple of topics, honorable mentions. By the way, if you don't know why there's a British spelling, you'll find out later. Some stuff I have no time to go deep into, just scratch the surface. So legal requirements, if you work for the government or work for Red Hat and develop software for the government, you have to take care of that stuff. Data center security, it's really physical security, like protecting the outer fence. Hardware, Intel security management engine, yeah, disaster. Browsers, I have no clue how browsers work. I have no idea of web security except for very small pieces. So if you have questions later, please don't ask about browsers. Ransomware, what I mentioned earlier, state-sponsored attack or cyberware, cyber terrorism, yeah, a whole very political topic. Just want to mention the most dangerous cyber terrorist of them all. That guy? Really, that guy. Because if you look at attacks on power grids in the US, squirrels are really dangerous. Humans, 3, maybe, but squirrels like over 1,000 power outages on the power grid. Yeah. And this is a really cool site. They have actually newspaper clips, maps, and proof of all the attacks they had on the power grid. Cybersquirrel1.com. Of course, with the wet factor, the most dangerous of them all, there's so many ways you can hack a human. Social engineering, like skills, CEO scam, they're just showing somebody, hey, I need money, and yeah. People like to give away passwords for chocolate. There was a rather interesting research community of Luxembourg. Yeah, dissatisfied employees. So keep your people happy, managers, and please don't be an ignorant manager. It helps also. So if your department, if your IT security people tell you there's an issue, please listen to them. And take care. So I'm very old, so that's an old monitor from back on the ages where we have like the big one, the super heavy ones, and that's a Xerox copy machine. And so if you take into security, users will find ways to work around that. So if you disable the screenshot feature, well, screenshot. And lastly, Internet of Things. Yeah, let's do that. So it's really, so people are working hard to make IoT secure, which is a big challenge because you don't have that much computing power, you don't have that much energy, and just to do crypto on a machine without much CPU power, much power consumption, is really hard. So, security bottom up. So, what would you do if you design a secure system? So, let's start with the beginning, hardware on the operating system. Find trustworthy hardware, yeah, Intel. Validate your OS. How do you validate your OS? But you can't trust your computer. And how do you get the public keys in a secure way to validate your OS? Yeah. If you secure, but it's actually not that bad. It helps a bit, except if you're a Google, and there are a whole lot of fun with UEFI because actually it's a security nightmare. You probably want to do firewall. You don't want to have like all your ports open. And remember, please update your system. And don't disable SLNs. So I think Dan is not here, but yeah. So don't make Dan Walsh unhappy. For applications, just probably most of you are any of you kernel developers here, or application developers? most of you, just assume that most of you do the applications. So don't run your application as root, especially if you run in the dword container or in any other container. So don't run your applications as root, even containers. You want to restrict them. So nice thing about containers these days, you get good sandboxing, encrypt all your stuff. So TLS, SSL, don't only TLS, so SSL is dead hopefully but soon. Encrypt all your data on the rest, especially critical things. Bind to localhost, so don't be MongoDB, you just have the ports open and without authentication. Yeah, strong authentication, I'll come to that later. And please update and restart, because updates don't help you to restart. So again, we want to do that, what people did a couple of hundred years ago or earlier, mitigation, defense in depth. So that's all forward from, I think, the 17th century, you see. So even if an attacker is able to compromise a small section, he can't use that to an advantage, and different parts protect each other. So, and finally, update, please. Don't become Equifax, which I think Apache Strata server didn't update a known security issue and leaked like a couple of 100 million records, so social security number, and so, yeah. Okay, now down to the examples. So this was originally a Python talk, but I'm not covering that much Python a bit, mostly the bad parts, which I'm responsible for. So if you develop an application, please consider to use a memory-safe, high-level language. So Rust is great, Go is great, Python is great, other languages probably too. On the other hand, if you do C, you know Fermat's last theorem about C. So you didn't have enough place to write all the theorem on the margin of the book. Okay, we have somebody who's a math nerd. Thanks, Rob. Okay, yes, I have bad humor. Even languages like Python have lots of dangerous features. So if you do Python development and use these functions, yeah, you have to take care. Even import. Import is dangerous if an attacker is able to drop in some Python code in a path where your application happens to load a plugin. We learned that the hard way, like I think 8 years ago, where the official wiki of Python.org was hacked by a combination of bad import and another attack I'll show in a minute. C types, that you do funky stuff with just unsafe C code in Python, yeah. And marshalling, pickling, yeah, come to that later too. Yeah, as a pickle is the Python serialization format, and what I said of Python UK, don't accept pickles from strangers. Yeah. API. So if you're an application developer, develop your API. Please consider to make your API and all the defaults easy to understand, obvious, and default by secure. And make consistent error reporting. So something, especially for a C programmer, so in C you don't have exceptions like in Python, so you either return 0 for OK and -1 for bug, or 0 for OK and 1, 2, 3, 4 for an error code, or maybe 0 for something went wrong and 1 it's okay. But there are at least 3 different styles, and don't mix them, please. It's just horrible. Please don't use developer-friendly default options, make them production-friendly. That means secure and tight and neaty, and have maybe a developer mode calling like, this is very insecure for but okay for development. Require authentication. MongoDB is was a bad example, should that change? And totally my fault, that one, in Python, you still don't verify certificates by default. Yeah, I'm working on that. It's rather hard because I have to break backwards compatibility. Files in I/O have a lot of traps, so just going a bit to more examples. One is called directory traversal attacks, just to show you some examples. So that's a download route for downloading files in a web application. You just join your base files, so valid files with some name, and just return the memory to open the file, return the file data, and yeah, the rest of the application takes care, just streams back the file to the browser. Which is okay, except you can do something like add a dot, so going back a path, and even more and even more and even more. And if your application happens to run as a Apache user, you can even read the private keys for your TLS encryption and security, and that's bad. So you have to verify any incoming input, for example, a way. So app's name, not actually an absolute name, so what you either have to forbid to accept any dot, or if you want to accept like subdirectories, a bit of them. At the end, if you create the absolute normalized path, you have to verify that the absolute normalized path is within your base directory. So change root for simple ways. Talk to race condition means time of check, time of use. If you first check if there's a file, and if there's no file, you just create the file and dump some data. You can abuse this kind of issues to make root like override important stuff. Because if you happen to time rightly and neatly and just inject a symlink between the check and the actual part where you open the file and write to it, yeah, then you can have any user override any path. Correct way is doing something like that, using features of the kernel of the operating system. So you force the system to exclusively create a file and have the file system kernel part thingy to make sure that there is no race condition. And you can't do that safe on your own. You have to rely on the kernel for that. Temporary file directories, similar. Don't use temp. Please create your private temporary files. If you use systemd services, systemd can create a private temp that cleans up afterwards. It's really neat. Most languages have a model or a package to do secure temporary files. There's even the glibc has some function for that. File parsing, another fun story. Just give you one example or a couple of examples. HTTP2, that's rather easy format. First you have a couple of headers, like separate by a colon, ended by a new line, and then if one empty line, and then the actual payload starts. Probably everybody with like a week of training in coding can write a parser for that, but to write a secure parser for that, well, Python took a couple of years. Because if you do it like that, so just iterate over the file content, split it, then it turns out there's a DOS bug, done of service issue. Because Python is just so convenient, you iterate over the file. Iterating over the file means read until you hit a new line. But what happens if the attacker never sends a new line? Well, you just keep on allocating memory and more memory and more memory, and eventually, yeah, you consume all the memory. So you do that right. So one of the many bugs we had, just to make sure that you read like maximum amount of characters and do some tricky things. Yeah. Who's using XML? This. So, okay, one guy. Sorry, two. I think two people. Yeah. I've done a lot of XML and in the past, but actually for a good reason. So we wanted to store data for a couple of thousand years, and XML is actually good for that, but not for other stuff these days. So XML is a fun old format from the old days where we had like this big CRT monitors, which with a couple of very interesting features most people don't know, called entities. So you can define your own placeholders. Yeah, in a way that gets nested and eventually it explodes. So we define A, we define B a couple times of A, C a couple times of B, etc., 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 and eventually it will just grind your CPU to a halt and consume gigabytes of memory, and it will explode. Well, or other stuff, you can actually include files from the file system or from a web resource and use that to circumvent your firewall or read data. So XML is actually complex and has lots of attack vectors. This is just a small collection of attack vectors on XML. So if you do XML, I've written something called diffuse XML. Also a long page that just explains some of the attack vectors. Yeah. Even trivial stuff like translation. So if you translate a program, you use getText. You have something called plural forms, that one, where you have different pluralization forms. Because languages don't agree how they make a plural. For German and English, it's all the same. So it's 1 and so 0 and 1 are the same. I think, yeah. 0. No, 0 is plural in English and German, and 1 is singular form. In French, it's a bit different. If you look at Celtic languages, it gets even more interesting. Russian, I don't know. Yeah, I'm happy I haven't had to learn Russian. Especially the language denial of service is fun because star means to the power of, and that creates a really long number, and explode too. And hacking, that was fun stuff last year. They now have a way to use DNA to hack computers. So if you have like a DNA sequencer, you can use specially crafted DNA to hack your DNA sequencer. Input validation, just to everybody knows SQL attacks. So don't create your own queries like that, please, because you can do it like if you attacker sends a specially crafted password username, he can just terminate your expression and make the word always true. Well, yeah. If you run stuff in a shell, like so subprocess model in Python just runs your program, and if you use the shell feature and don't use the secure exec VE API, you can do stuff like, hey, command my file and also remove the system. Bam, and gone. And they're even so shell, LDAP, XPath, XQuery, NoSQL databases are also affected. So if you use like a not sure what's cool these days after MongoDB, ArangoDB or so, yeah. ASIN1, yeah. So now my pet peeve, crypto. Please don't invent your own crypto. Please don't implement your own crypto. Yeah, so crypto is really hard to get right, even for trained professionals. It's one fun talk from Filippo from Cloudflare. So he showed how to extract a key from a very tiny bug in the elliptic curve implementation in Go. So there's I think there's 7 zeros after the dot. So there's sometimes a carry bit, so like a carry over bit to the next one, misplaced. And he could abuse this very tiny error to extract the private key. And the actual implementation test vectors, nobody saw the error for a long time, yeah. And it's written by Excel specialists, by professional. After I said that at my last talk, I got some complaint, and actually I agree, please implement your own crypto, but never use it, because actually implementing your own crypto and sharing it with a coworker and having your coworker hack your own crypto help both you and your coworker understand crypto much better. And eventually we'll learn, no, we don't want to use our own code in crypto. Our own crypto code in production, that way around. Yeah. Simple, so yeah. Don't do that, please. It's horrible. What I mentioned earlier, please verify your certificates. Please use TLS. So if you use Python, do that. I'm trying to fix that for a long time. 3.7 is going to be a bit better, still not perfect, yeah. And if you're having a hard time to actually get a certificate, Let's Encrypt is really awesome if you have a public service, with a small catch, because Let's Encrypt is also very secure in the sense that it pushes all unique certificates to a append-only cryptographically signed log. So don't publish any of your internal host names on Let's Encrypt. Consider the stuff I'm working on, free IPA. It also includes a internal CA based on DocTag and NSS code. Yeah, NSS developers. Yeah. And don't roll your own cert validation. So if you happen to have the idea to validate certs on your own, yeah, I tried that just for validating the host name. So you have your certificate, you have to validate that the host name you're connecting matches the certificate, which looks easy. It's actually really hard. We have like $6 in Python at least just to match the host name, just a string to another string, which is complicated, really. So in 3.7, it's going to be much better. I'm using official OpenSSL API introduced in OpenSSL 1.0.2, which also means that Python 3.7 will no longer work with LibreSSL, which is unfortunate, but yeah, because they don't implement that API yet. I have an outstanding bug report. Random numbers. So you need random numbers quite often for anything like tokens, password salts, whatever, and you don't want to use your default random model. Like Python random is really bad. It's a Marzano twister, so you can predict the next numbers. You want to have a cryptographically secure pseudo-random number generator, CSPRNG, or you may also hear in some other context like FIPS, DG, yeah. So that's actually something you can predict what's coming out, but you do some tricks to make the actual prediction state then unpredictable. And yeah, ask Bob. So in Python, you use urandom. If you have Golang, cryptrandom, Rust, I have never written Rust, it's a shame. But if you use C, so the new kernel actually have an API to give you a secure random number and even some flags, so you can ask the kernel, is your internal state already initialized or not, which is relevant for IoT devices because they don't have that many random bits when they boot. Passwords, please use any of these algorithms. Don't use the old ones, because you want to have passwords that are both hashed in a secure way. Salted, it means the same password hashes to a different value because you prefix it with an extra salt. And yeah, and please also use a constant time comparison function that doesn't terminate early, because your CPU will just optimize your checks and your C code will optimize your checks, but you always want to have the same time, because even small timing differences can be used by an attacker to reverse engineer your passwords. Or don't use passwords at all, use some of these stuff. So social logins, single sign-on Kerberos. If you don't need to have your own user database, just use GitHub, Twitter, Facebook, Google, which has some privacy concerns, or FreeIPA, what I'm developing. Yeah. I think you have to keep in mind AES and RSR are not secure by themselves. They're just some fancy mathematical tricks and functions, mathematical artifacts. If you use them just the raw form, it's super insecure. Because if you use AES in raw form, it's also called an electronic codebook, and that happens. Oh yeah, that's the symbol of the last conference I gave that talk. So it's the PyCon UK. And what's happening here, although every block is encrypted properly, you can still see the structure of the original document, because every number is encrypted to the same value. So it doesn't hide the actual structure of the image. And you do that with the DEF CON logo, that one happens. So you want to use a special mode, or there are a couple of modes that make AES actually secure. So any of this except another one in the middle. I think I had to learn the hard way when I started to play with crypto. Most of the algorithms you see here are something called have something called malleability. So they encrypt your data, but encryption doesn't mean that an attacker can't modify your data. So you have to use some tricks to make sure that an attacker is not able to switch some bits in your transfer. So for example, if you send a package to your bank, say, yeah, send that guy like $10, and the attacker knows which position of the message this 10 is, then he can just modify some bits and make from $10 like $1,000. So it's easily possible, unless you use special protocols to protect your payload. That's called MEC, so Message Authentication Code, which you have to do the right way, because if you do it the bad way, I just take my data, append a secret token, and use that as a checksum, that doesn't work out with SHA-1 and SHA-2. So you have to use, for example, HMAC or modern algorithms, SHA-3, like to secure against that kind of attacks. Or you use directly a so-called authentication, authenticated encryption with additional data algorithm like Gauss counter mode, which uses something called a nonce. So now you have like data and a key and a nonce and additional data. And the nonce stands for number only used once. And that once is really, really critical, because if you happen to use the nonce 2 times, the same key, just store both, so exclusive OR operations on all the bits in your data, okay, then you get like that one. And if you happen to know what the original image was, then you can get the other original image back. So nonce misuse is a big issue, don't do that, and that's why you should never use GCM mode to encrypt files on a disk. It's basically only for streaming use. And don't use the same key on multiple systems, because you would need to make sure that you don't misuse the same nonce. So, bad crypto, don't use bad crypto, so you use any of the stuff. PKC is version 1.7, yeah, don't use that. There are a couple of good algorithms, but don't use them in a bad form. I highly recommend, for example, project I'm having out a bit, PyCA Cryptography. They use a standard called Fernet. Fernet is a combination of AES with proper checksum and some other tricks that help you. And basically, you just put in a raw data and your key. It does some magic internally and gives you a string. That one is secure. And you can't even do like streaming encryption, because that's really hard. You can only encrypt the blob for some reason, or I can't explain it like in 5 minutes. I think, 5 minutes. I think that happens quite often. Security is the issue. How do you transport any kind of key material, like passwords? You have like starting a container and want to have your MySQL password or your private keys, and to get them in is rather hard. And the suggestion, so command line is bad, because any other process on the system who's in the same process group or the same PID namespace can see the password on the command line. Plain text files are also a bad idea, because the system gets compromised. People tend to use Git to store private files and just check them out, until people just push the AWS keys to GitHub, which happens quite often and can cost a fortune. Yeah, yo. So you want to use a kernel keyring, which is a good idea, except if you're running containers, because kernel keyring just keeps your private data in a secure space in the kernel memory, so user space processes can't get that information from the kernel, assuming the kernel is secure. But the API is not yet namespaced, so you can't use kernel keyrings in containers yet. Some guys are working on that. encrypt your data, HSM or TPM are working fine unless you have an AMD processor. They have a software TPM in the chip and that was broken too. Yeah. And please, 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 even plain text files are better than hard coding your keys. So they want another fun attack. Basically, they want the guys who made that, Matthew Green, a professor from, I think, Illinois. He wanted just to make fun of people creating logos and funny names for attacks, so he made the duck attack. So, summary before running out of time, give you some time to ask me questions. So, to avoid security issues, I think the most important thing is educate yourself, educate your coworkers, and learn what could go wrong. I think if you don't know what could go wrong, then you have no way to figure out why you're doing mistakes. Code usage, so don't invent your own stuff, reuse existing projects. I know people tend to dislike projects like OpenSSL. Yeah, OpenSSL is not perfect, but it's probably much better than anything that any of, except maybe for these two guys, could develop. You want to restrict everything, so make small compartments, have them communicate over ways, and just don't allow just free-floating information. Same like you would like, don't, yeah. Okay, my brain is breaking down. Oh yeah, basically the same you wouldn't do like developing multiprocessing or threading code. So try to isolate your different parts and restrict the amount of information that can flow. Encrypt both on disk and when you transfer information, even if you transfer information within your data center, because you never know who's listening even inside the data center. Update, yeah. So Equifax, yeah. And as a German, please take care of privacy. So don't store more information than you need to store. So any information that could be stored could be abused to harm people. As a German, there was one story. So the city, I think Amsterdam, used to have a census on all the citizens in the 1940s, 30-ish years. And they also keep track of the religion of the people who lived in Amsterdam. And that was later abused by the Nazis to kill a lot of Jews. And these days I'm getting more worried about people just hating foreigners, hating different religions, that this information could be used to do another genocide. So the German, please take care of privacy. So, questions? Or if you want to take me, yeah.
What's your take on password policies?
My take on password policies are, so password policy, they used to have like ideas like rotate your password very often and do like have a number, have a special character, upper lowercase thingy. You mean that? For instance, okay, for instance, so the question was password policies. My take on password policies is try to avoid passwords. So let the user choose a rather long passphrase, like a whole sentence made with some funny typos, and use features like UTF tokens. So combine your password with a two-factor authentication. So YubiKey or 2FA, what Google is pushing. I have a rather mixed feeling against Google. On the one side, Google is keeping a lot of data. On the other side, Google is pushing a lot of very innovative and new things in the CA sector and security sector, and UTF is one of the standards. So I would go for passphrases, long passphrases, and UTF rather than arbitrary rotation policies. They don't work out. And even NIST changed the policy like a year ago. So NIST just said our old policy was stupid.
Do you use some password manager?
Yes, so password manager. The question was if I use a password manager. Yes, I use a password manager. I only have like a bunch of passwords, including the password from Password Manager in my head, and the remaining passwords are just randomly generated long passwords I store in a Password Manager. I don't want to name any product because they're all upsides and downsides, so you use whatever you think it's most secure, but yeah, use a Password Manager. It's actually a good idea.
Online or on your computer?
The question was online or on my computer. Yes. And so let's see. You want to have it convenient and want to have a backup. Yeah. I don't want to name any products here because they have all good and bad sides. Yeah. More questions? Any comments disguised as questions? Do you have enough time so you can just give me feedback?
So maybe. Yeah.
Okay.
One question. On one of your slides, there was a mention that you should not use environment variables for storing secrets, which is kind of what I see as most common policy or approach in a lot of virtualized or nearly any environment.
So the question was about environment variables to transport secrets into like your application or your container platform. So envars are problematic because for multiple reasons. For one, you have a proc file system, so you can do like an attacker could do a directory traversal attack and use that to read proc/self/environ and get all your envars back. So you expose your envars. Also, there are sometimes debugging features like I know Python tools, I know PHP info, who just give you information about your process, including all the envars. So envars are a bad place to store critical information because there are just too many places where envars could be exposed to an attacker or just randomly spilled out somewhere in your program. I've been working on a tool in the past to have, rather than pushing your secret into your container application, give the container application some kind of API to pull the secret from an endpoint. That's called, what I mentioned right in the beginning, called Custodia. Okay, it'll take a while to get back. Oh, can I do that? Okay, it's called Custodia. It's still proof of concept. We try to avoid some of the issues. Where is it? Oh, on that slide. So it's called Custodia Secrets Management. We try to solve the issue. We haven't done it yet. We have proof of concepts to remove envars. Yeah. But so if you get the kernel keyring feature, then your actual container start daemon or your container infrastructure could push secrets into the kernel keyring in a way that only the application and that namespace can read back the information from the kernel keyring. That would be awesome, but we don't have that yet. So writers are working on implementing namespacing for kernel keyring, but it's not there yet. I'm not sure what the time plan. I'm sure they're currently working on that. So I only knew that somebody was looking into that. You had another question?
Yeah, I just had a comment on the salts.
Yeah.
Like all these things are real, right? You showed us examples how someone got hacked. Maybe a nice example of not using salts is a really bad idea is LinkedIn. If you remember a couple years ago, they passwords leaked. They had everything encrypted, but by not using salts, they were susceptible to the, I think it's rainbow attack, right?
Yeah, rainbow
so
table attack.
If users had password like orange or apple, then you instantly get like
I can just
passwords.
to explain that quickly. So the comment was about password hashing and salting. So what salt does, it guarantees that you don't map one plain text password to the same resulting hash. So even if you have a hashing function that's secure, you don't want to be susceptible to rainbow attacks. So rainbow attack means you create a large dictionary of known hashes to the actual words. And for trivial password like password 1 or hack me or 1, 2, 3, 4, 5, that's very easy. And for most algorithms, it takes split nanoseconds or less. And with rainbow table, you have usually like 8 bytes prefix or 4 bytes, 6 bytes, lots of bytes. So you would increase the rainbow table to I can show that on this, to I would need to use every atom on Earth to store the state of the information. So you make it rather hard to make an attack on your hacked passwords easy. Does that make sense? Okay, I'm not sure if it's making sense at the moment, but yeah. I think we're almost out of time. If you have any more questions or comments, hi.
Why is bad idea to use username for salt?
It's not. So the question was why the bad idea is to use a username for assault. I think it doesn't make sense to use the username for assault. You want to have a random number that nobody can guess in advance, because usernames are actually rather evenly distributed. You have lots of people named like Smith or Jones or Bob.
But string is different. They have same password.
Yeah, but the actual entropy of the string is not different. So you want to have a super high entropy, and you don't want to give the attacker the chance to pre-calculate that information or reuse information multiple times. So you can easily just store a salt with your password hash and use that. So, just create a random number, large blob, like a couple of bytes, and it's much more secure than having something that an attacker could know in advance and have a very low entropy. Because human names have a very low entropy. They're just a couple of letters usually, unless you're in the Czech Republic, they're a bit more letters. And so it most people look lowercase letters are 26 letters, and yeah. So the actual space where you have usernames is very small compared to long random numbers and exhausting the whole number space. It's just, if you go to the trouble to use a proper algorithm, you can just use a secure salt. So it doesn't make sense to reduce your security that much if you already got to the trouble, do it properly. So, any more questions? You have like 10 seconds or so. Okay, find me afterwards if you want to just ask me.